In this lecture we will see few important signals. First signal is unit impulse signal. Continuous time unit impulse signal is also known as direct delta function. Unit impulse signal is defined as infinity at t is equal to 0, otherwise its value is equal to 0. Also, its area under the graph is considered to be equal to 1. This signal is represented by an arrow with strength of 1, where the strength is representing the area under the graph. The word unit in unit impulse signal is representing the strength which represents the total area within the graph. The second test signal is unit step signal, which is also referred as Heaviside function. The value of unit step signal is equal to 1 when time is greater than 0 and is equal to 0 when time is smaller than 0. At t is equal to 0, the value of unit step signal is equal to 1 by 2. Here, the word unit signifies the value of the function when time is greater than 0. However, the value at time is equal to 0 will also change. The third signal is unit ramp signal, which is equal to 0 when time is smaller than 0 and is equal to time when time is greater than or equal to 0. There can be numerous ramp signal, but there is only one unit ramp signal. If we consider a general ramp signal, then the value of ramp signal will be equal to mt, where m is any real number and t is the time greater than or equal to 0. But when m is equal to 1, it becomes unit ramp signal. Similarly, we have unit parabolic signal. A general parabolic signal is equal to 0 when time is smaller than 0 and is equal to mt square divided by 2, where m is a real number and t is the time greater than or equal to 0. If the value of m becomes equal to 1, then it becomes unit parabolic signal. These are the 4 elementary test signals which are used for testing and certification of various electronic components. These test signals actually represent the behavior of very common natural phenomena, like unit impulse signal can represent the behavior of lightning surges that are caused within the nearby area where lightning has struck. The unit step signal represents the ideal behavior of a normal applied input, whereas ramp and parabolic signal represent particularly velocity and acceleration type input. All these signals are actually related to each other. Like the unit step signal is integration of unit impulse signal from mass infinity to the present point of time. In similar manner, unit ramp signal is related to unit step signal and unit parabolic signal is related to unit ramp signal. Besides these 4 test signals, we have another signal which is sinusoidal signal, which is actually the most commonly used signal. Now we come to our next topic, which is types of system. First category of systems is linear and non-linear systems. A system is said to be linear if it satisfies 2 properties. The first is additivity, in which suppose we have a system and if we apply 2 different inputs x1t and x2t, then the output will be y1t and y2t. But if we apply both the input signals x1t and x2t simultaneously, then the output should also be the sum of their independent outputs. The second property that need to be satisfied is of homogeneity. It states that if input is scaled by any real or imaginary number c, then the output should also be scaled by the same amount c. If the system follows these 2 properties, then the system is said to be a linear system. Let's try to understand it with an example. Suppose there is a system whose output is equal to constant a multiplied by the input xt plus another constant b. First we apply 2 different inputs x1t and x2t, giving their independent outputs y1t and y2t. Now we apply x1t and x2t signals simultaneously. The sum of x1t and x2t will be referred as xt, which will give the output yt, which is equal to constant a multiplied by x1t plus x2t plus v. Now, for the system to be linear, the output when we have applied both the signals simultaneously should be equal to the sum of outputs when the signals are inserted separately. However, in our case, this condition is not true. So, the example which we have taken is of a nonlinear system. The second type of systems is time invariant and time variant systems. A system is said to be time invariant if its input-output characteristics does not change with time or the response of a system remains same irrespective of time. In other words, we can also say if delayed input xt minus t naught produces delayed output yt minus t naught, then a system is said to be time invariant. Let's try to understand with an example. Suppose that we have a system whose output is equal to time t multiplied by a function xt. First we provide delay to the input and will check what will be the output. Let the output in this condition to be equal to y1t, which is equal to time t multiplied by a function x t minus t naught. In the second step of finding whether the system is time invariant or not, we will provide delay to the output rather than input, the resultant output being equal to y2t, which is equal to t minus t naught into function x t minus t naught. For a system to be time invariant, y2t must be equal to y1t. But in this case, these two outputs are not equal. Therefore, the system in consideration is an example of time variant system. We have seen two categories of systems, linear and nonlinear systems, time invariant and time variant systems. In majority of the cases, we are going to deal with linear time invariant systems unless and until it is provided in the question itself that the system is not linear time invariant. You have to keep assuming the provided system is a linear time invariant system. Besides these simple signals, we have so many other signals which are comparatively more complex, like sync signal, sampling signal, rectangular signal, triangular signal, and so many other signals. Similarly, besides the linear and time variant systems, we have so many other types of systems like causal and non-causal systems, static and dynamic systems, and stable and unstable systems. And you have to read all these things in detail, but not in control systems. You have to study all these things in signals and system. Actually, if you want to cover the syllabus in a very organized manner, then you should start your preparation with signal and systems and electrical circuits. These two subjects should be the first subjects because basics of these subjects are also used in other subjects. Like if you consider signals and system, then few of its topics are used in communication systems. Some topics are also used in control systems. Similarly, if you talk about electrical circuits, then few of its concepts are used in electrical measurements, analog electronics, as well as power electronics. If you really want to do your preparation in minimum amount of time, then it should be in a very organized manner. For that, you should start your preparation with electrical circuits and signal systems. By doing so, the later subjects will also help in revising the topics of those subjects which you have already covered.